Now we'll get some practice in on graphing another absolute value function. Our function here is fairly complicated. Negative 2 times absolute value of 3/4 x minus 3 plus 1 on the outside. In order to graph this, we are going to find the vertex, and then we'll find one extra point on either side of the vertex. For our vertex, let's remind ourselves that we're going to let the inside of the bars become 0. So we'll set that 3/4 x minus 3 equal to 0. In order to solve this, we'll begin by adding 3 to both sides to move the 3 off the left into the right side. This will cancel out the 3 that's on the left, and our equation will now be 3/4 x equals 3. Now, many students get stuck at this point because they're unsure of what to do with the fraction. If you have a fraction next to x, we will multiply both sides by the reciprocal, or the inverted form of that fraction. The inverted form of 3/4 is 4/3. We'll multiply that on both sides. When you multiply a fraction by its own reciprocal, that will cancel both fractions on the left. Therefore, the 4/3 and 3/4 on the left will both go away, leaving us with only 1x. Of course, I'm not going to write the invisible 1, but we need to remember that it's there. On the right, if we take 3 times 4/3, that actually cancels out the 3 on the bottom with the 3 on the outside of the parentheses. This leaves us with an x of 4. Thankfully, we don't need to do any more math in order to get the y-coordinate of the vertex, because that's whatever number is outside of the bars and added on. Therefore, we'll say that our vertex has an x of 4 and a y of positive 1. We'll place that on our graph now. We'll go right by 4 from the origin and up by 1. Now we'll get 2 additional points on the graph on the left and right in order to finish our absolute value graph. We'll first need to get the rate of change. Now, this problem is not quite the same as our previous problem that we worked when graphing absolute value functions. The reason why is because we have a number inside of the bars multiplied by x and an additional number outside of the bars, which will also be multiplied by x. When you have a number on the inside and outside, in order to get the rate, we'll have to multiply those two numbers. Therefore, our rate of change will be negative 2 multiplied by 3/4. If we take negative 2 times 3, we'll just multiply straight across and get negative 6 divided by 4. This is not in lowest terms. We can simplify this by dividing both the top and the bottom by 2. If we do that, we'll get a rate of change of negative 3 over 2. So once again, our rate of change is a fraction. And when we have a fraction for the rate of change, the numerator tells us how far up or down to go, and the denominator tells us how far left or right to go. First, we will go left. Since our denominator is 2, we will go left by 2. And then we will go down by 3 because we have a negative number. We'll need to make initial marks on the y-axis to demonstrate. Then at the end of this line, which is 3 units long, we will place a dot. Then on the right side of our vertex, we'll do the same. We'll go right by 2 rather than left. We'll need to make some more marks on the x-axis to show that. Once we've gone right by 2, we will again go down by 3 because the number on the numerator was negative 3. We'll place another dot there. Then we will connect the dots, making a V shape for our absolute value. We'll draw a diagonal line through the vertex and the left dot, and another diagonal line to the right. This will give us our absolute value graph. If you'd like to calculate the position of those points, you can do so. Our vertex was at 4, 1. We went left by 2 and down by 3. Therefore, we are taking 2 away from the x and taking 3 away from the y. Reminding ourselves that left reduces the x and down reduces the y. If we take 4 minus 2, this will give us 2 for our new x. And then if we take 1 minus 3, this will give us negative 2 for our y. That's the location of our left point. We can do the same on the right side. On the right, we went right by 2 and again down by 3. This means from our vertex of 4, 1, going right by 2 added 2 to the x, but took 3 away from the y. Therefore, our new x is 4 plus 2, which is 6, and our new y is 1 minus 3, which is negative 2. Notice it's exactly the same y as what we got for our left point. Now, using those 3 points, we have constructed our absolute value graph, drawing diagonal lines to the left to complete the picture.